Okay, so today we are starting unit number 7, which is absolute value functions and reciprocal functions. So today we are just talking about absolute values. So the official definition of an absolute value is that it is the principal square root of the square of the number. So what that means is that if you have a number and you square it, and then you take the square root, that's the absolute value. So basically all they're doing is saying that it's the same number, but always positive. Okay? So for example, the absolute value of 6 we know is 6. Absolute value of negative 6 is also 6. Okay? Okay. Yeah, so this is the symbol of absolute values is we write it like this with 2 lines, like that. Not really. I usually make them like quite long. No, because square brackets mean something else. No, it's got to be these. No. Yeah. Okay, so this is how it's represented. We have to represent them this way, okay? Okay? So on a number line, we can say that an absolute value is just the distance from 0. So this is something we do all the time when we're like traveling, right? If I'm driving to Calgary, I don't say I'm driving negative 300 kilometers. I say, oh, I'm driving 300 kilometers, right? So
you're going west.
So moral of the story is absolute values can never be negative. Okay? So here we have 7 different examples, and we can blow through these really quickly. So Ashley, what's the answer for A? 3. Christine, number or letter B. Got it. Kayla? Yeah. Okay, so inside here we have 8, but because that negative is outside, it's going to be negative 8 exactly. Okay? Andrew, can you give us B? Negative 8, awesome. So that negative 8 becomes positive, but then there's a negative outside. Okay. Josh? Answer to E. Exactly. 7 plus 7 is equal to 14. Okay. Paul, F? Exactly. So we get negative 4 inside those absolute values, but we get 4 overall. Teresa? G. Negative 9. You got it. So we get negative 9 inside is equal to negative 9. Okay? So the trickiest thing, honestly, is just if you have that negative sign outside of the absolute values, it still makes ultimately the value negative. Only if it's inside the absolute values does it become positive. Yes, Erin. Okay. Because when we solve the absolute value part, so just this part here, it becomes a positive 9. So it's like having negative 9. And then, good question. Josh, did you still have a question? There's quite a few in your homework. Okay, so now they're asking us to graph these. So to start off, we'll start really nice and simple. We'll say y is equal to x. So we get to graph it, and it looks like that. Okay. So now we say, okay, now graph y is equal to the absolute value of x. So we can say, well, We know when x is positive, the absolute value doesn't change it at all. So we'll just do that part for now, and we'll say, okay. That part will look exactly like that. But when x is negative, so all of this part of the graph, what happens to x if it's in an absolute value? It becomes positive, exactly. So it looks like that. Okay? In this case it is, yes. Because we know that when x is negative, so for example, if we had negative 1 right there, it would be like that. Exactly. So what they're actually doing is they're taking this part, and all they're doing is reflecting it in the x-axis. So in our notes, we can write when y is positive, so like for this part of the graph, the graph of the absolute value is the same. So it's handy. The positive part of the graph always stays the same. When y is in the negative part, so everything below that x-axis, the graph is a reflection in the x-axis. Okay? So, yes, Aaron? Yeah, so all the x's in this part are negative. So when we put that into our absolute value here, just like I said, negative 1 becomes 1. So the point that would have been here is now here. Negative 2 becomes positive 2. The x's, but then what they're giving us is they're giving us our y value. Okay? So our x is still negative. This is still at negative 1 on the x-axis, but our y becomes. The y is like our solution, right? So our x is still negative. It's still at the negative part, but our y becomes positive. Okay? So because this part, because our equation was y is equal to x. So when x is 1, y is 1. When x is 2, y is 2. X is 3. If it was y is equal to negative x, it would go the other way. Okay? Okay, so if we go down to here, we can see that our equation of our absolute value is kind of like two different pieces, right? The part that goes up to the left and the part that goes up to the right. And so the thing with this is that each of these pieces has a different domain. Okay? And so we can write these in what we call a piecewise function. So for example, in this one, let's say that when x is greater than or equal to 0, our function is represented by x. And when x is less than 0, it's represented by negative x. So for example, if x is equal to 5, you say, oh, that's pretty easy, like it just stays as 5 because x is greater than 0. But if we say x is equal to negative 5, then we can say, oh, well, when x is equal to negative 5, we have to substitute that in to negative x. So we say negative 5, like that, which becomes positive 5 again. Okay? So imagine this having like brackets around it. So when you substitute your value for x in, that negative sign stays outside the brackets and you have to bring it in. So that's why we have negative, negative 5. Like that. Okay? So if you're making a study sheet, this is something good to put on it because it's kind of the basic piecewise function, and it also shows that absolute values are always positive. Okay? So we're going to make things just a little bit more complicated now. So we have y is equal to x minus 3. So we'll go. So go like this. Like that. So that's the line for y is equal to x minus 3. So if we were to write y is equal to the absolute value of x minus 3, we know that for all the positive y's, so the positive part of our graph, it's going to stay the same. So it'll still look like this. Okay? But then the negative part of our graph gets reflected in the x-axis. So it looks like this. It's like a backwards check mark. Okay? So if we go down here, we're going to write it in our piecewise function now. So when you're writing these, this part here comes straight from here. Okay? And then the other part, you're going to substitute it. Remember how in our first one it was just negative x? You substitute it in right for that x. And then you could also simplify it. So we could also make this negative x plus 3. Okay? For this part here, when they talk about where the graph is positive and where it's negative, if you have the graph drawn, we can see that on our graph, the point where the graph changes is right here at 3. Okay? So we know when x is greater than or equal to 3, we talk about the positive part of the graph, and when x is less than 3, we're talking about the other side of the graph. But we can also find this algebraically because you won't always be given a picture of your graph. So to find that, you just go x minus 3, taken right from there, is greater than or equal to 0, and you get to go plus 3, so you get x is greater than or equal to 3. Okay? And then for the other one, you know that you start with, it must be less than 0, and then you do the same thing. You find that. Okay? So we know that all absolute values can be defined in pieces. Okay? And then so for example, 2, A and B, to write this in a piecewise function, this is how you start. You go, okay, f at x is equal to, and then you do one of these brackets. And then for the positive side, we know we can pull that straight from there. So we go 3x plus 2, and then we say, okay, 3x plus 2 is greater than or equal to 0. So we know that's the positive part. And then for this side, we go 3x plus 2 in brackets with that negative, and we know that it's the negative part. Okay? But we want to simplify this a little bit, so we can go, okay, f at x is equal to 3x plus 2. And then so for the negative part, I'm just going to pull that negative sign in, like that. And then for these here, we can simplify these just like we did with the other one. So we go 3x plus 2 greater than or equal to 0. And we can subtract 2 from each side. and we get 3x is greater than or equal to negative 2, and divide by 3. So we get x is greater than or equal to negative 2 over 3. And then we just get to write that right there. Okay? And then the other side is going to be the same, except it's that x is less than negative 2 over 3. Okay? So after we've written it in the piecewise function, we can actually test this to make sure it's right, which is nice. So we'll go test. And I'm going to use a positive example. So we go 3, so we just substitute 1 in for x. We go, okay, well that's 3 plus 2 is equal to 5. And that's good, because when we test this, we should always get a positive number, because it's our absolute value, right? Like if you're not getting a positive number when you're testing it, something's not quite right. Yes, Josh? So you can choose any test value you want, but when we're testing the positive side here, it needs to be something that fits this. So I chose 1 because I know it's greater than negative 2 over 3, and it's an easy one. Like you wouldn't want to choose something like, yeah, exactly. 1 would be a good one. 0 is even better. Like you can choose 0 as your test value. Okay? So what would be a good test value for the negative 1? So we need something less than negative 2 over 3. Even easier. Okay. Kelsey suggested negative 1. So like I said, make it as simple as possible. You want to eliminate every chance of you making a mistake. Okay? That gives us, so when we substitute that in, we know that we substituted into our negative 1 because that's the one we're testing. So that'll give us 3 minus 2 is equal to 1. So as a side to yourself, right? The test must result in a positive. They don't have to equal each other, exactly. So we're not verifying anything. We're not trying to make the left side equal the right side or anything like that. We're just trying to make sure that it's a positive number. Okay? So, for example number 2, we start it the same way and go, okay, well for the positive part, we can pull that straight from out of our absolute value. The negative part is 4 minus x. Okay? And then we know we go, okay, well,